Hello everyone. Last time we introduced the background and definition of microsegmentation. Today we will talk about its implementation. Here we use a distributed VXLAN network as an example to describe the working mechanism of microsegmentation. On CE series switches, microsegmentation is applied to a VXLAN network to control packets on the destination VTEP based on the GBP. To control bidirectional traffic, you need to deploy microsegmentation on both the source and destination VTEPs. Before learning about the local forwarding of layer 3 packets on a VXLAN network, we will first briefly introduce the network to help your understanding. Leaf 1 is the endpoint of the VXLAN tunnel and connects to VM1 and VM2. Access traffic between VM1 and VM2 only needs to be forwarded through Leaf 1. VM1 belongs to EPG1 and VM2 belongs to EPG2. If VM1 wants to access VM2, after VTEP1 receives packets sent from VM1 to VM2, it obtains the source IP address and destination IP address from the packets. According to the source IP address, VTEP1 searches for TCAM entries based on the longest match rule and obtains the ID of the EPG to which VM1 belongs. According to the destination IP address, VTEP1 searches for the routing table and finds that VM2 is also connected to VTEP1. That is, packets only need to be forwarded locally. According to the destination IP address, VTEP1 searches for TCAM entries based on the longest match rule and obtains the ID of the EPG to which VM2 belongs. VTEP1 searches for TCAM entries based on EPG1 and EPG2 to which VM1 and VM2 belong, respectively, to obtain the GPB between EPG1 and EPG2. Then VTEP1 performs traffic control based on the GBP. Assuming that the GBP between the two EPGs is denied, access from VM1 to VM2 will be denied. As we mentioned earlier, when microsegmentation is applied, the destination VTEP performs traffic control based on the GBP. In local forwarding scenarios where the source VM and destination VM are on the same device, it is quite easy to obtain the EPG information. In inter-device forwarding scenarios, the source VM and destination VM are located on different devices. How is EPG information transmitted? The answer lies in the VXLAN packet header. The source VTEP sends microsegmentation information to the destination VTEP using the G flag bit and group policy ID field in the VXLAN packet header. Now, let's see how inter-device forwarding of layer 3 packets is implemented on a VXLAN network. The following applies if VM1 wants to access VM3. After VTEP1 receives packets sent from VM1 to VM3, it obtains the source IP address and destination IP address from the packets. According to the source IP address, VTEP1 searches for TCAM entries based on the longest match rule and obtains the ID of the EPG to which VM1 belongs. According to the destination IP address, VTEP1 searches for the routing table and finds that VM3 is connected to VTEP2. After packets are encapsulated with the VXLAN header, the packets are forwarded over the VXLAN tunnel across devices. During VXLAN encapsulation, VTEP1 resets the G flag bit in the VXLAN packet header, encapsulates EPG1 to which VM1 belongs into group policy ID field of the VXLAN packet header, and sends the packets to VTEP2. After receiving VXLAN packets sent by VTEP1, VTEP2 decapsulates the VXLAN packets. VTEP finds that the G flag bit is 1 and obtains EPG1 of VM1 from the group policy ID field. According to the inner destination IP address, VTEP2 searches for TCAM entries based on the longest match rule and obtains the ID of the EPG to which VM3 belongs. VTEP2 searches for TCAM entries based on EPG1 and EPG3 to which VM1 and VM3 belong, respectively, to obtain the GBP between EPG1 and EPG3. Then VTEP2 performs traffic control based on the GBP. Assuming that the GBP between the two EPGs is denied, access from VM1 to VM3 will be denied. That's all for today's introduction. Thanks for watching and see you next time.